Okay, so welcome to lesson 11.8, surface area and volume of spheres. And not that this means anything to you guys, but I'm actually doing this on spring break, sitting in the stateroom on my cruise ship because I need to get ahead of making movies. So before we start lesson 11.8, though, I want to just quickly do this extension lesson, which is on solids of revolution. And we've actually already done some problems like this on USA Test Prep. It's kind of obvious, but we're just going to go through this. A solid of revolution is a three-dimensional figure that is formed by rotating a two-dimensional shape. The line around which the shape is rotated is called the axis of revolution. For example, if you take a rectangle and rotate it around a line that contains one of its sides, you produce a cylinder. So you literally picture that rectangle coming up off the top of the paper, going back down, making a 360-degree revolution, and you have a cylinder. So for A here, this would be it would revolve and it would be a cylinder, and you could actually go ahead and figure out the volume of the cylinder based upon the dimensions that you're given. And on lesson B, problem B, that triangle, that right triangle, when it revolves, is going to be a right cone. If you wanted to go ahead and find the dimensions, or find the volume of the cylinder, excuse Ryan there.
What do I do?
It's making noises, sitting
The
in the bed next
papers
to
are
me.
falling.
Okay, you realize everybody's hearing you. So anyway, so the dimension, radius is 4. 4 squared is 16 times 3.14. That's going to be the area of the base of the cylinder times a height of 9. So I need my, oops, wrong button, my calculator. And we have 3.14 times 16 times 9, and this cylinder would have a volume of 452.6, and that was just from rotating 360 degrees a rectangle that would have had an area of 36. Over here to our cone, this is going to be a circular base, so 2 is the radius, 2 squared is 4, times pi, which is 3.14, times the height, which is 5, and then since it's a cone, has a pointy top, we divide by 3 for a volume of 20.9, and that's from a right triangle, which has an area of 5 being rotated 360 degrees. So on these problems here, you could go ahead and also find the volume. The work is done here for you below, but this again is going to be a cylinder. This shape here is actually going to be a composite shape, 2 cones stuck next to each other. So now that we've gone over revolutions, let's talk about our warm-up. Find the area of each circle. Well, if the radius is 17, 17 times 17 is 289 times 3.14, and I'll pull these away, but we are going to have some rounding issues because the book is using a pi button and we use 3.14. If the diameter is 7.8 divided by 2, the radius is 3.9 squared times 3.14, and either way you're going to round to about 47.8. More review for finding the volume of each solid. We have a cylinder, the radius is 6, so 36 times pi times the height is going to be about 1130.4. Rounding issues once again because the book is using pi button and we are using 3.14. And for our cone, a radius of 3.1 squared times 3.14 times a height of 11.8 divided by 3 because it has a pointy top, And 118.7 is what that's going to round to using 3.14. Find the circumference. I don't think we've talked most about the circumference. You're going to remember circumference is pi just times the diameter. So if we have a radius of 48, 48 times 2 is 96, times 3.14 is going to be approximately 301.4. Book has 301.59 because of rounding issues associated with using a pi button. So as we said, we're going to learn in this lesson about surface area and volume of spheres. So first of all, we have to understand what is the true definition of a sphere. A sphere is not a circle, Ryan.
It's not?
No, a circle is how many dimensions, Ryan?
2?
And a sphere is how many dimensions?
3?
3. See, if you had had a better 7th grade math teacher, you would know this.
But you were my 7th grade
But I was a 7th grade math teacher. I'm sure the children at home are loving listening to this commentary.
I
So
know,
a
they
sphere
like more than you.
is a set of all points in space equidistant from a given point. This point is called the center of the sphere. So like a center of a circle, we have a center of a sphere. The radius of a sphere is a segment from the center to a point on the sphere. Any place you draw a line from the center to a point on the sphere in any direction is going to be a radius. A chord of a sphere is a segment whose endpoints are on the sphere. Just like in a circle, a chord is a segment whose endpoints are on the
and like
circle.
On a lamp, a chord is what you use to turn it on.
Are you going to stop talking?
Sorry.
A diameter of a sphere is a special chord that contains the center. As with circles, the terms radius and diameter also represent distances, and the diameter is twice the radius. So first off, we have theorem 1111, which is the surface area of a sphere. The surface area of a sphere is 4 times pi r squared. Since we're dealing with surface area, our radius is squared because it's a two-dimensional representation. Surface area of two-dimensional. Now, while I'm here, in the interest of time, I'm going to talk about the volume of a sphere is 4/3 pi radius cubed. So you will notice the similarities here when we're talking about the volume of a sphere. It's three-dimensional, it's radius cubed, and instead of 4, it's 4/3. For surface area of a sphere, it's multiplying by 4. And you might also remember that when you were finding the volume of a cone or a pyramid, you multiplied by 1/3. So you can start to see some correlations between the different formulas that will help you remember them. So we are going to find the surface area of this sphere. The radius is 8. 8 squared is 64. Times 4 is 256 times pi. When we do it in our calculator, because we're going to multiply by 3.14, we actually get 803.84. I'm not going to keep saying every time that you will have rounding issues because we are using 3.14 and the book is using a pi button because I think I've been saying it for 3 lessons now and you are probably getting tired of me saying it. Ooh, look, standardize, test, practice, aka SAT, but they can't say that because they don't own the rights to the SAT. The surface area of the sphere is 20.25 pi square centimeters. So what is the diameter? As you can see here, they use the formula, plugging in 20.25 pi. The pi's cancel out, divide each side by 4. 5.0625 is the radius squared. 2.25 is the radius, but don't get confused. They asked for the diameter. So 2.25 times 2 is 5.5. And we are correct. So exciting. Let's see how well we've paid attention. If the diameter of a sphere is 40 feet, find the surface area. Ryan, do you remember the formula for surface area of a sphere?
No.
4 times pi.
I said no.
Okay, you can do this part. Would our radius be squared or to the third if we're talking about surface area?
Squared.
Squared.
Oh, nice. The guess.
So the diameter is 40 feet. If your diameter is 40 feet, Ryan, what is your radius? If the diameter is 40, what's the radius?
Oh, 20.
Thank you. He does know. 4
You're a wizard
times
high.
pi times 20
go.
squared. He's so excited. 20
No,
times
my
20
runner got out.
is 400 times 4 is 1600 pi, which is going to be approximately 5,024. And guided practice number 2, if the surface area of a sphere is 30 pi. Do you remember the formula yet, Ryan?
What do I look like?
4 times
Oh,
pi
they just hit a home run.
times radius what?
Squared.
Thank you.
I don't like this.
Okay, so I'm going to cancel out the...
You told me not to talk.
I'm going to cancel out the pi's. 30 divide both sides by 4 is 7.5 is the radius squared. So the square root of 7.5 is approximately 2.74. Great circles. Sounds fascinating. If a plane intersects a sphere, the intersection is either a single point or a circle. If the plane contains the center of the sphere, then the intersection is a great circle of the sphere. So basically, a great circle of a sphere is a circle that contains the center of the sphere. The circumference of a great circle would then be the circumference of the sphere. Every great circle of a sphere separates the sphere into two congruent halves called hemispheres. Hemi meaning half. And where have you seen the word hemisphere before? When you're talking about the northern hemisphere, or the southern hemisphere, or the eastern hemisphere, or the western hemisphere of the globe. So now we're going to use the circumference of a sphere. In a sport called sphering, hey, I don't make this stuff up. It's right there in the book. A person rolls down a hill inside an inflatable ball surrounded by another ball. I think I'm nauseous. The circumference of the outer ball is 12 feet. Imagining rolling down a hill inside a ball inside another ball.
That would be fun.
Okay, find the surface area of the outer ball. So once again, we're going to roll. I need to picture this. You have a hill. Let's draw it in color. And you are going to roll in a ball
inside another ball
down a hill. The outer ball has a circumference of 12 feet.
It's ball section.
Find the surface area of the outer ball. So if the circumference of the outer sphere is 12 feet, 12 pi feet, then the radius is 12 pi divided by 2 pi. So that's 6 feet. Okay? And then using the formula, 6 squared is 36 times 4 is 144 pi. And if we use our calculator, we're going to get 144 times 3.14 equals 452.16. In example 3, the circumference of the inner ball is 6 pi feet. So if the circumference is 6 pi, divide that by 2 pi. So the radius is 3. Actually, don't divide by 2 pi, just divide by 2. 6 divided by 2 is 3. Yeah, we got that. So find the surface area. So the surface area is 4 pi r squared. 3 squared is 9. 9 times 4 is 36. And 36 times 3.14 is 113.04, rounded to 2 decimal spaces. Imagine that the interior of a sphere with radius r is approximated by n pyramids, each with a base area of capital B and a height of r. This exercise basically takes you through how to figure out the volume, the formula for the volume of a sphere. Okay? So volume is going to equal N, okay, times 1/3 capital B R. This is going to take you through this whole formula if you really wanted to. We do not need to justify the formula in this class. We simply need to remember that it's 4/3 pi r cubed, where r is the radius of a sphere, and I also remember cubed because it's volume. A soccer ball has a diameter of 9 inches. Find its volume. So if the diameter is 9 inches, the radius is 4.5. 4.5 times 4.5 times 4.5 is 91.125. Yes, on your scientific calculators, you can just do 4.5 to the third times 3.14. Now, how I deal with this 4/3 is I multiply all of this by 4, and then I divide by 3. Times 4 equals that number divided by 3. And you get 381.51. Now comes a lot of fun. Find the volume of the composite solid. The volume of the solid equals the volume of the cylinder minus the volume of the hemisphere. So basically it's hard to see in this picture, they've basically scooped all of this out. Okay, so you're going to find that this work takes you all through it. I really think you should be able to do these problems by now. You find the volume of the cylinder, you subtract what you found using the volume of the hemispheres, which is basically the volume of a sphere divided by 2. So instead of 4/3, they just did 2/3, or 1. There you go. And you would be able to solve this and get 8/3 pi. And if we were using our calculator, 3.14 times 8, so that number divided by 3 is approximately 8.37 on our calculators using 3.14. So let's do some guided practice. The radius of a sphere is 5 yards. Find the volume of the sphere. The volume equals 4/3 pi radius cubed. So 5 times 5 times 5 is 125 times 3.14 times 4 is that number 523.33. So 523.33. A solid consists of a hemisphere of a radius of 1 meter on top of a cone with the same radius and height. So I want to try and picture this. I have a cone. It's my cone. And I have a hemisphere that sits on top of it. Ooh, it kind of looks like ice cream. So this has a radius of 1. It's going to be easy because 1 times 1 times 1 is going to be still 1. With a cone with the same radius and height of 5 meters. So first I'm going to do the hemisphere. And the volume is 4/3 pi radius cubed. Now when I'm going to multiply all of that by half, I could just do half of 4/3 is going to be 2/3. I'm going to do that. It's going to save me a little bit of time at the end. So 1 times 1 times 1 is still 1. Times 3.14 is 3.14. Times 2 divided by 3. So the volume of the hemisphere is basically 2.093. Even though this is round to 2 decimal spaces, I'm going to put 3 right here and then round again at the end. So for my cone, the volume is going to be 1/3 pi r squared h. So radius squared, 1 times 1 is 1, times 5 is 5. 5 times 3.14 equals 15.7, divided by 3 is 5.233. So I'm going to add the 2.093 plus 5.233, and I'm going to get about 7.3. There we go. Wow, we matched exactly on this one. So we round to 7.33. And the book has the same answer. A little seasick doing this here on a boat while the thing is rocking. So the things I do for my students, well, it is rocking to me. Ryan says it's not rocking. But it's time for the daily homework quiz. Then I can put this all together, and when I land tomorrow, I can upload
When you land?
yet another video. Dock, whatever.
I didn't know the boat was flying.
He's so annoying. Find the surface area and the volume of each
You're
sphere.
so
So for the surface area, I don't need to write the formula out every time. It's 6 squared, which is 36, times 3.14 times 4. So the surface area is going to be about 452.16. For the volume, 6 times 6 times 6 is 216 times 3.14 times 4, and then I have to divide by 3. 904.32. Let's see how close we are to using when we use a pi button. There we go. Those are the answers that the book has. We have done them correctly using 3.14 for pi. So now find the surface area and volume for each sphere. Here we have, ooh, look at that. We have a great circle. They've tried to confuse us here. Diameter of 12.4. So my radius is 6.2. Surface area, 6.2 squared times 3.14 times 4 equals 482.8. You could also do 6.2 times 6.2 times 6.2, that's radius cubed, times 3.14 times 4 divided by 3 equals 1007.45. That's my volume. That's my surface area. There you go. Obviously a little bit of differences in rounding, but you know why. And a great circle has a circumference of 16 pi. That means its diameter is 16, its radius is 8. Find the volume of the sphere. 8 times 8 times 8 is 512 times 3.14 times 4 divided by 3 equals 2,143.57. And there's more. Find the radius of a sphere with a volume. Ooh, now they're giving us the volume. They're trying to get tricky on us. 4/3 pi radius cubed. So 4 times 3.14 divided by 3 is going to be 4.187 R3, 4445.18. So I'm going to do 4,445.18 divided by 4.187 gives me 1,061.66229. Now here is the problem. On this calculator, I do not have a cubed root button, but I know you're excited. I do on my iPhone. Why do I feel like the boat is moving? Oh, because the boat's moving. So
I don't feel it.
if I do 1,061.67 cubed root, I get about 10.2. So my radius, if I've done everything correctly, should be 10.2. Woohoo, we match. And for the last problem here, find the surface area and the volume of the solid. So let's do the surface area first. Oh, surface area of a cylinder. Oh, Mrs. Falk, we haven't done that. That's prior grade information, yes. So the cylinder would normally be made up of 2 circles, and this, if you remember from the flying can video, would open up to be a rectangle. We only have one circle though that's a surface area. So we're going to find the area of that circle on the bottom. 4 squared is 16 times 3.14 is 50.24. So that is the surface area of the bottom here. Area pi r squared. Now we need to find the surface area of this rectangle, which is the circumference of the circle multiplied by the height. So to get the circumference of the circle, the diameter of 8 times 3.14, that gives me the circumference of the circle. I'm going to multiply that by the height of 4, and that's 100.48. Now I need the surface area of the hemisphere. Well, if remember, the formula is 4 pi r squared. So half of 4 is 2. The radius is 4. 4 squared is 16 times 3.14 times 2 is also 100.48. The surface area of half of the sphere is the same as the surface area of the rectangular surface on the cylinder. So if I add 148 times 2, because there's 2 of them, plus 50.24, I get that the surface area is 251.2. Now for volume, I much prefer volume. Area of the circular base was 50.24 times the height. So the volume of the cylinder is 200.96. For the half of a sphere, so 2/3, half of 4/3 is 2/3, pi r cubed. So 4 times 4 is 16, and 16 times 4 is 64, times 3.14 times 2 equals that number, divided by 3 is 133.97. So 200.96 plus 133.97. Whoops, messed that up. 200.96 plus 133.97 equals 334. Let's see how close we are. Okay, there we go. This was 334, so our only differences are, of course, our rounding issues, because we're using 3.14 and the book uses pi. There you go. Here are some homework problems from the mini lesson on revolutions. And then here's where you would find your problems for homework from the information on surface area of and volume of spheres. Hope you have enjoyed this thrilling lesson aboard Independence of the Seas.